everyone. Welcome back to the Your Project Shepherd Construction Podcast. I am your host, Curtis Lawson, and today we're going to be talking about alternative wall assemblies. And joining me today for this discussion, I've got three folks in the room, one of which you have seen and heard before if you've been on here, Toner Kersting with Toner Home Matters.
Howdy.
Another repeat guest across the table from me is Bradley Hirdes with Ordinary Architecture Practice.
Hello.
And you were on, I think, season 1, our first season.
Wow.
And so that was
OG.
Ages ago. That's like a whole 7 or 8 months ago that released, probably like a year ago that we recorded it, but 7 or 8 months ago that released. And a first timer today, we've got Jeff Ehrich, and Jeff is the owner of Seaside Construction and Coastal ICF Supply out of Galveston, Texas.
Thanks for having me.
And I had the pleasure of this crew going on a trip to Cleveland, Ohio here. What was that? Back in March or April?
Snow. So that feels forever ago.
March or April, we did this trip to Cleveland, and we visited Trimco, who owns and manufactures the Nudura ICF products, which ties into our discussion today. So Jeff is a distributor through his ICF company for Nudura here in Texas. And Jeff, you also do turnkey installations on those too, right?
Yeah, and we also supply the Tremco sealant product. So the XO Air 130, which we'll get into a little bit more today, and Dimonic 100, which is another piece of the sealant towards the outside of the ICF block. And yes, we do installation as well.
Cool. So if you're here in the greater Houston area or the Texas region, you want to do an ICF project, Jeff's your guy. If you're a builder or if you're a homeowner, either way, Jeff can sell you the product. He can install the product. He can be a consultant on the product. So hit Jeff up if you're interested in doing ICF projects. So today I wanted to talk about, as I said, alternative wall assemblies. So we've kind of been building generally the same type of structures in the U.S. ever since the U.S. has been around. So back in the 1700s, and some variations on that, right? So back in the 1700s, started off doing timber framing, and then in the 1900s, we shifted to balloon framing using dimensional lumber. I guess today it's called platform framing is a name for it. But current framing techniques, were kind of the walls or the first and second floor, if it's a 2-story house, is separated by a subfloor assembly. So we've kind of been doing things more or less the same way, using wood products with a finished material on the outside of the wall and the inside of the wall for a long time. And that's worked well for a number of years, but I think now that we've had changes such as tighter energy codes that we have to comply with, climate migration, which Toner's talked about a lot, the rising cost of energy, concerns about natural resources, things like that. We're starting to use some of these new ways of building a house, new materials to build the exterior of our houses. I wanted to bring you guys on because, Jeff with the ICF stuff, and then Bradley, I think we mentioned this in some previous episodes, is working on some 3D printed home projects. And Toner's kind of all over the place, involved in a lot of these different things. And actually, Toner has some different methods of building walls using more of the traditional techniques, or some different ways of assembling that wall to help us achieve what we want to achieve.
I think it's important to note that the reason why we're talking about these alternative wall assemblies is because of primarily, it's not a code problem, right? The code's not forcing us into this. So it is an elective procedure to choose these alternative products. But a lot of it is because of, from my side, it's because of the resiliency factor. Just a standard built stick frame wall that, you go out and you buy a typical structure, custom production, spec home, it doesn't matter. You're going to get 2x4, some sheathing, some Tyvek. They call every weather resistant barrier Tyvek, right? It's just all Tyvek.
It's the Band-Aid.
It's the Band-Aid, right?
The Q-tip.
And then they slap some cladding on the outside, cladding on the inside. That's what you get. That was the exact same thing in the 80s and the 70s and the 60s and the 50s. Really saw balloon frame go away after World War II. So we have not had a functional shift in how we build walls pretty much anywhere in the United States in a very, very long time. So why do we need to do this now? And it really is climate migration. It's the resiliency factor. Now, Jeff is builds primarily on the coast, so he chose intentionally the worst place to ever build houses in the United States,
True.
right? And Bradley is looking at this from a design sensibility also, not just a resiliency factor, speed, also in that quest for trying to manage the cost of a structure. So today, when we're discussing these, it's not just about, can we do this cheaper? That's actually, in my opinion, the least part of this conversation, because in order for us to extrapolate what is a cheaper wall assembly, we need to look at more than just the constructible cost, how much it costs to build this, but what does it mean to the long-term durability and those costs associated with it? So that actual savings is typically extrapolated over the life of the structure, and we still suffer from the average homeowner in Houston, 5.5 years of ownership. On Galveston Island, the average ownership, especially once you get to what's called the west end of the island, so 51st Street over, is 19 months, the average ownership. And that's because we can get into a whole conversation. In fact, we're going to have a conversation on coastal structures coming up soon, and we'll discuss why that is less than ownership. So there's a lot of points. And when I talk about my side, what the wall assembly that we typically utilize, it's for more than just cost. So I want to get that out there right now.
Going along with that, I think it has a lot to do with the motivation of the market and the client, because, the common theme that I see on the coast is, everyone says this: I want a nice house. I don't want it over the top, but I want it strong as hell. That's what they want, right? Of course they do, because, hurricanes come, we have rising tides and all that wave action against the house. So, my clients that come in, when I start talking to them about alternative ways to build a structure to make it even stronger than we currently are doing, boy, oh boy, the light bulbs go off. And what I'm curious to see is how the marketplace would react to something like that between Galveston and Houston, and say, someplace in the Clear Lake area. How important is that? How you're going to build a 6,000 square foot Clear Lake home. You obviously, you have the wherewithal to do that. But are you still motivated to do an alternative wall assembly? Are you still motivated to talk about ICF or 3D printing or something like that? And for me, it's almost an easy sell down there. I bring up ICF and they're like, oh my God, let's do it tomorrow.
Mm-hmm.
But I feel like it, and we've talked about this in the past, ICF is great on the coast, but I think it should be all the way up through Conroe, in my opinion. Hurricanes hit us all over the place up here. And we have, moisture infiltration and mold issues, on and on and on it goes. I think that that's a key thing, because you have certain people that are worried about the price tag, and then you have certain people that they want to know about the technology. They want to build a good, strong home. So it's really interesting what the marketplace is doing right now with ICF.
So why don't you take a couple minutes and just explain, like I'm a fifth grader, right? What an ICF is and how it's built.
So ICF is called ICF because it's an insulated concrete form. And there's different manufacturers out there. There's Nudura, there's Fox Block, there's Build Block, there's a couple other manufacturers. But what it is, it's basically a large Lego. Inside the middle of the Lego is hollow. And so you have 2 5/8 inch foam on the outside of the block and 2 5/8 inch foam on the inside of the block. And then the core construction depends on the engineering and what you want to accomplish. So you can have a 6-inch concrete core, you can have 8, 10, 12-inch concrete core. Now, obviously, the taller the building, you're typically the larger the core. Or, we have that new client coming up. He wants to build a home that's going to withstand 250 mile an hour winds. That is most likely going to be 10 or 12-inch core.
That's actually the finger of God. Like, that's not even a win. That's
which I'm super excited to build, because it's going to be a fortress. But so the way ICF is constructed, let's just talk about Houston, Texas, or Houston up here. So slab on grade, you stub up the rebar about 2 feet. And then you take the block and you just start laying the perimeter of the wall. So it's usually the perimeter, the outside perimeter of a wall, and then the interior walls are wood or timber. They can be metal. You can do ICF walls on the inside, but it becomes a lot more difficult to do that. And so you lay these blocks out. You run about 2 courses, and you start from the corners and you come in. You run your tape measure for all your openings. You get the centers of all the windows and doors, and then you start cutting where those placements are, and then you bring the rest of the block to those openings, and then you get to the level you need to, you pour concrete. I mean, that's the simplified version. There's bracing and all kinds of other stuff that goes with it. But yeah, I really believe in it. It's a great way to build, and I think that we should be doing more of it. So. And
how did you get here? Because you didn't just wake up one morning and say, I want to do something different. I want to complicate my life today.
How long do we have? COVID hit, and I kind of was looking around at my marketplace, and I said, man, there's a lot of builders that just showed up on this island. They're doing a lot of spec homes. There's other custom home builders down here. And I was like, I got to figure out a way of doing things a little bit better. I dealt with moisture infiltration in some of my homes. I dealt with mold issues in some of my homes. We had to remediate a couple of these projects for some of our clients, which is, that hurts not only the pocketbook, but it hurts that you just built this great project for a homeowner and you're like, man, we have these issues. And so I contacted, I did an internet search for ICF coastal builders, and I really couldn't find anybody anywhere in Texas. And I found this guy in Pensacola, Florida. And I just started emailing him out of the blue. Hey, my name's Jeff. I have some questions for you. And he emailed me back, with a lot of information. And so after about 2 weeks, he probably got annoyed by me. He's like, hey, if you ever want to come and just, check us out, fly on down or fly over, whatever it is. And I'll tell you all about it. So I was like, okay, I took him up on it. Well, the guy rolled out the red carpet for me. I mean, I was really impressed. I mean, his name is Thomas Andra, by the way, Andra Custom Homes in Pensacola, Florida, if you're ever out there. Great guy. He spent a week with me. He brought me to his office. He showed me the product. He introduced me to his trades. I mean, he went so far as to, the day I left, sending me links to Amazon. This is the product you need to bend your rebar. This is the type of lift you need, this and this and this. So I got back and I was really inspired, and I was like, this is what we need to do here. Why is no one building with ICF on the Texas Gulf Coast? I mean, Pensacola is just right down the road. So that's how I got into it, really.
Awesome. And now you have a project under construction right now, correct?
We do, yeah.
Okay.
Yeah.
And that house didn't start off being designed as an ICF project.
It did not. That's correct.
That's not a lot of fun, right?
It's not a lot of fun. But it did afford me the opportunity to really do a comparison from stick framing to ICF, because that's the big question. So, when you're looking at any new technologies or different products, what's the very first thing somebody asks you? Okay, sounds great, but what does it cost? Like what does the 3D printing actually cost? What does the ICF actually cost? What does it cost to actually put a 1/2 inch of blue board on the exterior of the house and tape it and all that other stuff, right? So this structure was originally designed as a stick frame home, and luckily for me, it was actually also engineered as well. So I did a full line item budget on every single thing on that stick frame. And then the homeowner came to me and said, hey, is there any way to make this a little bit stronger? And I was like, well, okay. It's this thing called ICF. So we switched over, and now I had a full set of architecturals for stick frame, full set of architecturals for ICF, and the same thing for engineering. And I literally just did side by side a spreadsheet, took this out, put this in. At the time, it wasn't right at the height of the
lumber price issues.
But it was just started to dip down a little bit, but it was still pretty high. It was a 5% difference on a $1.2 million house, which is nothing.
Mm-hmm.
I mean, absolutely nothing. So it was a no-brainer. And today, I would say we're probably around 10%, but still, on a $1.2 million house, 10%. I mean, it's going to be constructed with all the benefits of ICF. It's a no-brainer for us down there.
So you're adding $100,000, $120,000 if it's 10%, right?
Yep.
So, but you're gaining energy efficiency. You're gaining strength for storm resistance, termite and pest issues are overcome.
And the biggest thing for us, and we talk about this ad nauseum, is the likelihood of not having moisture infiltration and mold issues. I mean, that's the biggest thing for us down there.
And to be honest, and to be clear, so when people are listening to this, that cost is actually aggravated because this is a coastal ICF job, not a normal ICF job.
Correct.
So ICF is not a vapor barrier. Moisture will drive through it, just like any other concrete mass wall, CMU, tilt wall, frame and pour. If you don't do anything to stop that moisture drive, it will happen, and it happens at a very, very high rate on the coast. So this is not only an ICF product, but it's an ICF product that then has all the seams are sealed, and then we have a liquid applied vapor barrier applied to the outside. So it's a lot more man hands on there, time and material. So it's a more expensive ICF project than normal.
So when you're designing a ICF house, you mentioned you took the same set of plans, right? And you had your stick frame plans and your ICF plans. It's not just like a straightforward thing to like change an ICF or a stick frame to an ICF or to something else. So I'm gonna redirect to Bradley over here, who's been patiently waiting in the wings as we talk about ICFs, because Bradley's an architect. We're talking about 3D, but from the design side as an architect, it's not as straightforward as just taking a stick frame set of plans and using ICF or 3D printing, because you've got a lot of factors to consider, right?
Yeah, that's true. I would say that, I don't know, engineering might be even more of a time-consuming process to change it over. But architecturally, you're mainly dealing with dimensional qualities of the ICF versus stick frame or whatever wall assembly it is. If you're changing the thickness of a wall, if you're changing any dimension on anything, you need to track that throughout the entire process. It's going to change the room widths, dimensions. It could shrink something so far that it's just outside of what code would require. So you just need to track it.
And the other thing is that if you're dealing with a fixed footprint, then everything, if you're going from stick frame to ICF, it's going to get a little smaller because your exterior wall is going to go from 6 inches to 11.25. But, if you have a bigger piece of property, it's more forgiving.
But Bradley, don't you have a little bit of a challenge with especially if it's a very distinct type of architecture? I'm just going to throw one out there. Let's say someone has come to you and said, Bradley, I want an English tutor. Mm-hmm. You're like, okay, I can totally tutor this thing out. And then they say, oh, by the way, I talked to this guy named Jeff, and I'm going to do an 11.5-inch ICF wall. How do you make an English tutor look appropriate when you have an 11.5-inch wall? Where do you set the windows, and how do you make it look appropriate on the inside, the doors? That's hard.
Right, exactly. So outside of dimensioning issues, you've got the detailing issues. Mm-hmm. And so, like you said, you have to think of wall thicknesses and how the windows sit within those walls, how the roof connects to the walls, just other detailing issues that especially when you have a very distinct style. Mm-hmm. So I feel like that question should be on the architectural exam. How do you make an English tutor look like an English tutor with ICF?
I do want to put out there that I would like to see the transitional tutor become a thing now. I want someone to
transitional tutor.
I want to get that.
How do you 3D print a craftsman style house?
There you go. Yeah, that would be the challenge. But it's the detailing, it's dimensional aspects, and then there's going to be other things that come up too, of course. But those are kind of when I say detailing, that's a big category to to capture a lot of things. Yeah. So you got to track it through.
I think we've talked about this a million times. Having the right team on board based on the product that you're using is important too. I've seen a lot of really bad ICF design. Oh, I know that you have too.
Yes.
So it's understanding the products, is understanding the limitations and the design requirements of those products to make sure that your architect is drawing something it's going to look good. It can actually be built and not have to have a bunch of tweaking done to it in the field. Yeah. So it's having someone who's familiar with those products that you're wanting to use.
Yeah. And you might make design decisions based on the material itself.
Absolutely.
I know I do when I'm designing a 3D printed house. You'll design a 3D printed house dramatically different than you would an ICF house, or even a traditionally framed house. So you want to, it's useful to start off knowing what material you're going to build with, in order to come up with a design that really works and really leverages the materials you're working with.
So let's take some time to get the 3D house out on the table now, right? We have an ICF house sitting over here on one side. Why don't you go ahead and tell us how you got into the 3D sector, right? Because that's a technology. It's not building a house. It's the tech company, right? Like that's how everyone wants to build this out, right? Oh, no, 3D printed houses, that's technology. That's not building houses. No, it's building houses. You can't get away from that. So how did you get into this, and tell us a little bit about your particular type of 3D structure?
Yeah, I have just a connection that was really interested in the technology. The places where we're building are outside of major metropolitan areas. Labor can sometimes be a little difficult to come by, or at least to coordinate. One of the benefits of 3D printing is you're eliminating some trades along the way. So it's less coordination, less people to try to, drive 40 miles out of where they normally would work. Especially if they're really busy, and everybody seems to be really busy right now. And so, one of my, partners in the industry was interested in this technology and all that it could offer, and did a lot of research and just found the right people, formed the right team, and decided to bootstrap a project. And I was just lucky to be part of the team. It was really fun to be able to design something new, design something, like you said, that's an emerging technology. And it really is like, it's not just the material, but it's the technology. It's how it goes up layer by layer. And so you're printing a 3D structure on a traditional concrete foundation, engineered foundation, and then the machine. There's multiple different types of machines that can print the size, a project the size of a structure of a building, and you go up layer by layer, similar to ICF. Jeff described it as 2 layers on the outside, with a core that would be filled later with the material. And this is a similar process. You're printing 2 layers, an outside wall, an inside layer, and then you're coming back and filling that core with an insulated concrete, or some sort of concrete or material that has an insulative property. And after you get to the top, it's of the top of the wall, it's framing, you're stick framing the top, the roof. Certain machines are capable of printing sloped roofs, so you could print kind of shell structures with these. Typically a little more difficult. And if you're going to be printing structures that are habitable, then you want it to be insulated and all the other things that we talk about here. And it's really difficult to do that on a shell style printed roof. So we find that the most efficient and best way to build is to print the walls and then frame something on top of it, frame a roof on top of it.
Do you guys, you putting rebar in as you go, or is it some type of additive to the concrete, or what PSI is the concrete you doing?
So the PSI kind of varies, and it depends on what material you're using, because you can print with kind of traditional concrete. There's also a lot of additives you can add to it to increase strength and mess with the drying time. I say mess with because your temperature and humidity is really a big factor.
Right.
And you found that out the hard way, right?
We did. Yeah.
Really?
When the concrete cures in the tube, because it's so hot out, you need to adjust, and you print out overnight.
Right.
Lots of night printing.
Love that night. We already have gone through. This is another. Just the next Michael Stipe song is night printing.
Night printing.
So, I love that idea, especially because the grid load is so much smaller at nighttime.
Mm-hmm.
So, and there is some power needed for this rig. This is not, a compressor and that's it. So, and it's not necessarily the loudest of construction activities.
No, it's very quiet.
It's very quiet. So, thinking about just all the things that come with, noise and disruption and power load, the idea that this is could almost semi-autonomously function at nighttime. You leave in the end at 5 o'clock, you come back, and there's more house that was there when you get there the next morning.
Well, and you can just print overnight with multiple crews, or you can print 24 hours a day with multiple crews as well.
Yeah.
And you just need a small crew of people to work the machine, operate the mixer, and just make sure everything is moving and flowing.
So are you guys mixing on site then? This is not coming from a plant?
Correct. Yeah.
Oh, wow. Okay.
So everything is
realize.
mixed on site in smaller batches. And that's really, the machine kind of necessitates that. You can't mix too much.
Because it goes so slow, right? Yeah.
Different machines operate at different speeds. And that's the other thing. There's so many variables with the type of machine that you're using. And
now is there horizontal and vertical rebar is it stubbed up at the foundation and then
there's
later?
Subbed up at the foundation, similar to what you described with ICF.
Right.
And then we're printing on top of that. And then we're not connecting all the way vertically. There are certain points, and again, this all depends on what the engineer specifies.
Right.
There are certain points, like there are areas where that need vertical reinforcement. It might be because of a load of the roof or something. But the reinforcement is done by placing ties from outer wall to inner wall when the print goes up, and then that cures inside of those walls. It's just a little connection between the outer layer and the inner layer.
So are you guys also using like a buck system like we do for your window and door openings?
That's actually a really good point, because both ICF and 3D printing are wall systems.
Right.
And they're not the complete wall system. They're a wall system. Both require non-3D printed or non-ICF materials to go into them. Windows and doors are most prevalent, right? So how we make that interconnection is it's an equally challenging opportunity. The good thing is we're working on ICF and 3D printing at the same time, and our resolutions are very, very similar to each other.
Yeah.
What works for one will work for the other. There is an industry gap in a product right now that we're needing. I think we've figured out how to get that through.
Well, Fox Block has got a styrofoam buck system.
Yep, and we have a meeting with them to see if we can rip it off and use it.
Why not? You could potentially do a combination. It'd be
if they don't care, right? Like they may want to say, well, if it's not a Fox Block printed house.
Well, maybe
I don't know. Hopefully they're cool and we can do that, but we'll figure that out. Now, on the 3D printed, your 3D printing can be your interior and your exterior cladding, correct?
Yes, that's right. So we have found the best way to leverage the economy of 3D printing and the speed of it is to print everything, all the walls. So interior walls, exterior walls are all printed material.
Awesome.
And then we're not furring out anything on the interior as well. Some companies will do that. They'll build the exterior wall and then stick frame the interior walls. And it's
what's the point?
Right. You're losing a lot of value there. And there's other ways. Some people don't want to see all the 3D printed layers. So there's other ways to go about and to approach it. But for the most part, like you're seeing the material, you can paint it. You have to seal the exterior, but you can also paint the interior.
But that requires planning out some of your mechanical stuff. So on the architectural side, like you're being strategic about where your plumbing is going to be, and like thinking about your finishes. Like you're going to see electrical conduit. So if the ICF is the finished wall on the interior, then you're actually putting like electrical conduit and boxes on top of the wall, right?
Yes.
So it becomes a design feature.
Yes, you can do that. That's usually the easiest way to do it. That requires the least amount of prep ahead of time.
We have another 3D printed project that we're about to begin. It's actually in really early design stages for an architect out of Amsterdam, and they've done some other 3D product there. And so, in order to lessen this, every electrical is in the floor. There's nothing in the walls. All of our air conditioning is vinyl polyline steel. It's all on the slab. So all my mechanicals are on the floor. And the plumbing, the only thing that comes up out of the floor is a plumbing riser. So it's very undisturbed. in this manner. And I like it. I've done AC inside slabs many times. So it just depends on how that slab finishes. But I like that idea. I think there might be some code things that we're going to have to address. Luckily, we're doing it also out in the sticks. So who's there to bust us, right? But when the code says you must have an outlet in the wall every 4 feet, it's the in the wall part of the code that I have to overcome, even though this is not on the wall, but it's 1 inch away from the wall. So we're going to have to get inventing with that. And I know that you guys can actually alternate that. So if we did have to put it into the baseboard, for instance, the printer can make up for that kind of stuff.
Yeah, that's right. As long as you pre-plan, anything is really possible. It's just a matter of what's the schedule dictating? What are the time constraints? Do you have the labor on site to be able to go along and to know, okay, when the machine passes here, we need to place this electrical box, for example.
But so this project that we have going on in Galveston right now, 2 out of the 3 of the mechanical trades have never done ICF before. So they were, a little bit like, oh my God. And, I need to charge you $5,000 more. I'm like, no, dude, no, you don't. But to your point about coordination, that's what we did. We got the first floor walls up. I said, all right, guys, let's meet on site, talk about your penetrations, where they need to be. We're going to sleeve them through. It's easy. I mean, going through styrofoam block is nothing. And I think they realized real quick, first of all, how many exterior wall penetrations do you need? And then how much stuff is really run on the exterior walls in the first place? If you really think about it, there's not that much stuff. A lot of it's on the interior framing for, your plumbing, and a lot of your electrical, your home runs are coming down from the center anyway. For us, it was an interesting, kind of discussion about how we're going to do this. And everybody got on board pretty quick. And I'm curious about the 3D printing stuff, though. How thick are your exterior walls typically? Are they like 12 inches, 10 inches, something like that?
We've printed 12-inch thick exterior walls and 8-inch thick exterior.
So the interior walls, if I heard you right, if you're doing the 3D printing, so everything, including the plumbing lines, are like adhered to the exterior of that interior wall. Is that how it goes? Or running conduit? I'm sorry.
Yeah, some of it is in the walls.
Oh, some of it is. Okay.
Yeah, placed in the walls.
Because you still have that cavity that you can always come up and then.
Oh, right. I keep forgetting about that. Okay.
Because then you can go back and fill it afterwards.
Oh, gotcha. Okay.
Now, the both of these products, to go lean into design, they actually require design. I'm going to bring up another ICF project that Jeff and I are on right now, where homeowner is very clear that he wanted ICF from the beginning. So we had just basically a rough sketch of what we needed. But there are going to be some wall assemblies that, afterwards designed, cannot be done with ICF. He has a crow's nest. So concrete has to sit on top of concrete. Can't just float out over space. So they have imagine a square, and then the roof pitches up, and then there's a crow's nest in the middle. Now that's wood frame.
That's right.
And the problem with mixing mediums here, especially in a wall assembly, is 2 totally different dynamics for vapor, moisture, wind, air, pressure dynamics. And it's not a good idea. So we have to try to say, if we're committing to this, we're committing to it 100%.
Yeah.
And the 3D printed house that Bradley did, he designed it. So he knew this from the beginning. He didn't hamstring himself with, I'm going to have to do this one chunk out of stick built. So it is a little hard sometimes to convert these things backwards. But the disappointing thing with the project that Jeff and I are on is we had these conversations with the architect.
Yeah.
Like from day one.
Yeah.
And we were very, very clear. And then he still drew a house that's going to have a mixed bag of wall assemblies.
Well, I think that goes back to what Curtis said about building your team, and understanding what everybody can bring to the table, and everybody understands what the motivation is and what the end goal is. I mean, that's super important. And that's been the challenge. And you and I've talked about this a lot. We've had, actually all of us had conversations about this. Sometimes everybody gets so busy doing what what they've all done for years and years and years, that when you can't come and bring a new concept and they have to do a deep dive into it and they really got to, figure all this stuff out, they're reluctant to do that. We see that a lot, mostly with engineers. Mm-hmm. But when you do get those folks that are, sorry,
engineer.
Sorry, engineers. I love you, man,
bro.
but sorry. But it's the truth. Come on. And builders are the same way, by the way.
Yeah.
We're very rigid. Once we find something that seems to work for us, so we can make money off it, we just keep going with it, right? So you have to have the personality, wants to do something different and do something better over and over and over again. But I think that's super important when you go down this road of whether it be ICF or 3D printed or any other technologies for new home. It's surrounding yourself with people that have an open mind, that are willing to dive into this and say, hey, we can do something better. We can do things a little bit different here.
When both of you are willing, so if someone wants to do a 3D printed house, they can just start with Bradley.
Yeah.
And he's going to make sure everybody that comes on after him is on board, has done this, but he's bringing in those protections from day one.
Mm-hmm.
With ICF, you can do it turnkey.
Yep.
So the builder doesn't have to become an ICF pro.
That's right.
We have another project up in Morgan's Point we're talking about. I've already gotten a phone call from all 3 builders that are bidding it, going, you're doing ICF? I don't know anything about it. And I'm like, you only need to know one person. And that's the subcontractor you hire to do a turnkey.
Yeah. That's right.
Right? But that wasn't present for last 15 years I've been in this industry. Every time I wanted to do something like this, I was the one doing all the heavy lifting, and that's not what we're here for. I mean, we want to consult on it, but I can't get myself to full time. And there'll be a manufacturer of the product, but he's not the installer of the product. And there was this big disconnect.
Yeah.
I think also just knowing that there's resources out there that you can use and tapping into those. I mean, I know when I was a young builder, which was a long time ago because I'm not a young builder anymore, but I kind of saw some of the sales reps that would come to the shop as annoying, like, oh, this guy just keeps showing up, he's trying to sell me something, right? But these companies have networks of not just sales reps, but technical support people to help you. Like, Nudura, fantastic people that work there that are very knowledgeable about the products that can help you install it. It's the same thing for pretty much every product that we use. And I think most builders don't tap into those resources and use those reps and technical people to help them when they run into a problem. They're like, I'll just figure it out on my own.
That's true.
Right?
That's true. I agree with that. I think the other part of it too, though, is for Bradley and I think we're definitely a minority for sure. And what I mean by that is that most people or most builders that have done ICF in the past or getting into 3D printing, either one, I think that they get into it because they have a client that comes to them and says, hey, this is what I'm interested in doing. Can you do this for me? And to your point about those 3 builders saying, I don't know how to do this, I'm bidding it. What I'd like to see in the industry and just in general, the building industry is for more builders, more architects, more engineers to say, hey, look, let's look at alternative ways to do things and let's look at the benefits of those things. And I think just speaking about that and talking to clients and other builders about it, raises interest, because who doesn't want to do a good job, right? And I even tell this to my clients every once in a while, like, sometimes when a build doesn't go that great, people get really upset, right? It's like you don't meet expectations and they want things yesterday and you're working through all this stuff. And one day I actually had this happen about a month ago. I sat down with a client. I said, you do know that, like, my goal is to build best possible house for you, like for your family, like your memories are going to be here forever. Like, I'm motivated to want to see you happy. Like, you do understand that, right? It's like, and they just look at you like, holy cow, this guy went deep. But seriously though, I mean, really,
but you're trying to reset them, right?
But yeah.
And then you say, hey, by the way, that tile's gonna stay crooked.
Yeah, that's right. No. But I think that hopefully, with this podcast and other conversations, we get builders and architects and engineers that are interested in doing something different. That's what I hope.
And I do want to point out, in both cases, the 3D printed wall and the ICF, we keep calling them alternatives, especially the 3D printed. It feels very alternative. Mm-hmm. And that's because, in my view, so many tech entrepreneurs are chasing that,
Mm-hmm.
and they get the idea that like, this is the newest thing ever, right?
Mm-hmm.
You guys are actually the wheel of the wall assembly. You're the OG. Because what you all are doing is not new. It's a thermal mass wall,
Mm-hmm.
which is the original building product. So we talked about wood frame. Before that was thermal mass, and that's it. You guys are just reproducing a thermal mass wall. So we're saying it's alternative. I would actually say you guys are the OG wall assemblies.
I'll take that.
And the wood frame is the alternative, right? So that's the reason why my organization loves this so much is thermal mass is so predictable, right? I can do those studies and I know how it works. And the thicker the thermal mass wall, the more long-term resiliency we do have. So that's why I'm down with this. I don't care to you. You will not find me saying alternative wall assemblies. We'll just say,
you said it like 5 times. Right?
I know, but I won't say that in a presentation. I will not call it alternative wall assemblies. Although I do walk into them. We don't start with them. We walk into them. Bradley and I had a project. We had a phone call this morning on it.
Mm-hmm.
Where we thought that on day one that was going to be ICF, right?
Mm-hmm.
Like we had that, and we're not there now, but we earned our way through that. That would be a very hard piece of architecture to make ICF work on.
Yes, the whole thing.
The whole thing would be hard.
Yes, could be parts and pieces, but
It was the continuous roof
Exactly.
amongst. There are what 4 or 5 separate footprint buildings.
yeah, there are really 3 separate conditioned spaces. Yeah, but it's all connected by one roof.
So what we
Yeah.
were going to have a challenge was bringing those demising walls up to the roof
Mm-hmm.
and not cutting off shared mechanicals between them.
Mm-hmm.
So we really would have had such an isolated space that it would have just aggravated costs. It would have been individual plumbing systems, mechanical systems, electrical systems. So it just wasn't needed.
Right.
I have a question though, since, we're talking about ICF and 3D printing, to kind of throw it back at you, because I'm interested in this. We've had conversations. Where do you think the energy code is going to, and what is it going to do to the traditional wall assembly? I mean, because I think that's a big question, because if it's going to add significantly more materials and labor to build this traditional wall assembly because of higher energy code, then what we're doing actually may make a whole lot more sense to a lot of people. And what do you think that's going?
We could have a whole conversation about how energy code affects the durability or the cost of a structure. I don't see that much of a big impact as we change codes, because also every time we change energy code, we're finding more alternative ways or more pathways through that code. And we've already crossed this pressure threshold, which is one reason why we had to do this, is one thing that's affecting the durability of the structures. I think that it's going to only justify this, but it would really justify it cost-wise if someone was approaching their energy code in a very, very poor manner. That would be if they were doing prescriptive. That says, I don't care what you do here, R38 in the walls, R this, R that, and all they care about is R value. I don't care about R value, but that's a very expensive code. With these wall assemblies, because of the pressure dynamics, we can do more with less. So we're actually able to your point, probably offset more of these costs. But that's only if we compare it to a very, very poorly designed energy plan. So for my business, we don't ever show you the poorly designed one because we lose that comparative.
Gotcha.
Let's talk about other alternative wall assemblies, to use the term that you don't want to use anymore. What other options out there other than ICF 3D printing are available? So one thing that we mentioned was just not a totally different material, but just a different way of assembling the assembly, like a Zip R, a continuous insulation product.
And that may feel like an alternative stick frame assembly for a lot of people, unless you're clients of ours, or we do a couple hundred of them every single year and we barely scratch the surface, but we are having that layer. And just to avoid brands, right? There's all kinds of ways of designing it. I'm trying to have that integral air, water, vapor, pressure, thermal barrier, but I need it to be a single assembly, because trying to make those functions work in disconnected pieces is very, very challenging. And the math and science just goes off the rails real fast. So I know there's some new products that are coming out that also achieve that. And I think that's really important because when I'm comparing the cost of these products, ICF and 3D printed, against a properly built and designed wall assembly, that price shrinks down even more, almost dollar for dollar, just about the same. Because then we have speed and efficiencies and all those things that come into play. I would say that if you are just building a wall with sticks, sheathing, and we still have builders out there that just stretch WRB across the open frame. Like, that's a very, very normal and common thing, which doesn't work.
Or
like,
thermoply.
A thermoply, yeah, something like that. And not that thermoply is a bad product, it just is misused in many, many cases. That's still the prevalent wall assembly. And it's just going to be in Texas. It's going to be like that in Louisiana. It's like that in New Mexico. And it's an unfortunate situation. So we have to bring the whole market up. I think that we have a big developer right in Austin that's doing 3D printed houses, right? And then we have some multifamily developers that are thinking about doing ICF as a whole.
Yeah.
So we're going to see this come into a larger scale, and hopefully some efficiencies of scale are derived from that, some familiarity with the product. That would be awesome. I could justify the next 55 and up community with share wall, all these products all day long.
Oh yeah.
Yeah. It's just getting into the developer's head about that really, really early. So that's a little bit of a challenge, and not feeling quirky when you did it. The presentation of these alternative materials doesn't need to be an alternative sales channel. It needs to feel significant and standard. So the psychology of that is interesting.
I think just the visibility of it and the familiarity with it. So the more people see it, the more they're going to ask questions about it. So I think it'll be something that snowballs. The more houses that you do with it and get out there in the world,
yes, it's
going to build. So what about SIPs panels? That's something that we used to hear a lot about. Now we don't really hear much about it. Some people still do it. What's your take on SIPs?
Yep, SIPs is structurally insulated panels. We do continuous insulation and kind of a SIPs configuration right now. We suffer down here a lot of windstorm, wind code that prevents us from doing that. The SIPs do have a lot of challenges with how they assemble at their joints, their corners, their inside corners, how you seal them. They unfortunately are sold by a lot of folks who don't sell them as a system. They sell it as a panel and hope that you can figure it out. And I've gone to many, many, many failure houses that are SIPs panels. That's unfortunate. And it's not because it's a bad product. It's just not applied properly. Another product which we are doing a lot of work on because of a high failure rate, not because it's a bad product, but because it's being used in alternative locations, is rammed earth. Rammed earth is the OG
material.
That's the OG material, right?
Slap some mud together and call it a house.
Yeah, that is really a dry climate product. So what's being utilized in what were traditionally 4-season climates, I'm gonna pick on North Carolina, but now we have such a high rate of heat and humidity, they're failing at a very, very high rate. And rammed earth, especially because we don't have consistency in that earth product. As it fails, there's other contaminants that are coming into the atmosphere. Those are challenging. Let's not talk about hay bale or straw bale or anything like that.
I've actually had people call me and ask about building straw bale houses. Like legitimately have asked me about that. Wow. Yes. Well, not in Houston, but
I was going to say
out in the country, like Brazoria County.
Oh, really? Okay.
Yeah.
Yeah, we've done them. We typically more in north of Fredericksburg, and we have did one in the Davis Mountains, and it was more of a kitschy kind of no one's primary space. I did one made 100% out of hemp bales, which is probably a very valuable house at this point. So we always have to get at least one drug reference in per every podcast. so
thing's going downhill.
But and we've done them full of chambray. I've done all kinds of products. The math and the science makes a lot of sense. Livability, durability, the localized climate. Will it be a good idea now versus 10 years from now? Probably not. We already know that the way that we have been building walls, it will not last. If we're not thinking ahead, then we're going to be always behind, right? So I appreciate both of you was definitely carrying the torch and probably educating. How many tire kickers do y'all go through? Like seriously.
Yeah, a lot. Well,
a lot of interest.
but thank God. I don't know about for the 3D printing stuff, but for the ICF stuff, there's a gazillion YouTube videos out of there. So most people that come to me, that are interested in it, have somewhat knowledge.
They've done some research on their own already.
Yeah.
One thing that I wanted to touch on before we wrap up, we just have a few more minutes here. What was some of the unique challenges that go along with doing some of these sorts of things? We touched on just the space requirements on the architectural side, right? Those walls being thicker. But what about, and this is something that you can speak on, is kind of our mechanical systems. So when you've got a mass wall, when you have a house that's hyper insulated, built really tightly, that requires proper mechanical design. You're concerned about oversizing systems, right?
We're concerned, and anytime we get to a very well-built structure, and we've been designing like this forever, we design it for as if it's a conditioned and abandoned space. It's both, because it's going to maintain its temperature, and so the AC system is not going to run, which is a great thing. We're all trying to not have the AC system run, but that's heating and cooling is actually the easiest facet of the indoor climate for us to manage. It's really about humidity. So how we design that dehumidifier to manage the indoor space is very, very specific for this style of structure. It is not the way the manufacturer says to install it. And I would say the majority of the issues I do have in failures with alternative wall assemblies is based on how that AC system is reacting to it. Because I've said it on this podcast before, an AC system is not a proactive tool. Ever is it a proactive tool. It only reacts to its environment. That environment is more than just the built environment. It is also how its occupation rate is, how it's utilized, what activities are going on in it. So it becomes easier and more complex at the exact same time. Less expensive, though, I would say that.
I mean, the three of us actually consulted. You brought us in on an ICF project in Mont Belvieu a few months back, right? And
yes,
they had some major issues, to say the least. But one of their big issues was their mechanical systems. I'm not sure that I can say that that was the biggest issue, but yes, it was one of the bigger issues were the mechanical systems.
Not cutting the windows the right size?
Yeah, well, but this goes back to the very beginning. We talked about planning, right? Mm-hmm. I mean, they aligned themselves with somebody that didn't know how to...
a trade show.
Yeah, these guys didn't really know how to apply the block. And if you remember, they put the walls up, and then the homeowners came one week and they said, the walls are up, now they're all down. And they were all up again and all down because the installer didn't know how to properly build a structure. So that I think that's where it originally started. And then, of course, the window and door buck system was not correct either. So it went, it snowballed from there. So that's where, what we do is, we provide the block in the installation. But I've also, and I've got to tell you about this too, and that goes out for anybody listening, is that we're not trying to be the guys that just keep all the information. And I've offered to other builders, said, look, we'll do the installation for you. Give me 2 or 3 of your guys. You can come and be added to our group, and they'll get an education on how to do it. And so then that way, the next time you want to build with ICF, we can help you. Or if your guys are locked on and know how to do it, they can do it as well. That job definitely was a lot of things going on.
Well, that was someone hiring somebody that had no experience with the product.
Yeah.
The house probably wasn't even designed properly to work with it to begin with. It was a comedy of failures. Just one thing after the other went wrong on that job.
Sure did, yeah.
So hire the right people to do these types of structures, build the right team, and set yourself up for success.
Most definitely.
So thanks, everybody, for being with me today.
Thank you.
You guys, tell us quickly, like website, social media, how they can reach you guys.
ordinaryarc.com.
ARCH?
Yep, ARCH. Mm-hmm.
This is Jeff Ehrich, Seaside Construction, and it's seaside-construction.com. For any custom coastal builds you need. And then Coastal ICF and Supply, we distribute ICF products, windows, doors, and actually fiberglass rebar, Owens Corning fiberglass rebar. So,
and tonerhomematters.com.
Tonerhomematters.com. We actually just put toner in any Google search and I show up on the first page.
Nice.
Like, you don't even need anything else.
Well, it's
Totally
probably not
organic.
hard to do, right? I mean,
No, the only toner on the internet.
Right next to copier supplies.
Right next to Copy Surprise is skin conditioning, and that's it.
All right. Well, thank you all for being with us today, for joining us on this episode of the Your Project Shepherd podcast. We appreciate you listening, and we'll see you next time.
Awesome.